There is a place in the known universe where nothing exists. Not the kind of nothing you've ever experienced. Not the darkness behind your eyelids, or the silence of an empty room at 3 in the morning. This is a different category of nothing altogether. A nothing so complete, so structurally absolute, that the word itself starts to feel inadequate. Scientists have a name for it. They call it a void. But this particular void, the one we're going to spend the next stretch of time inside, has earned a more specific name, a more chilling designation. They call it the Boötes Void. And some astronomers, the ones who've spent real time thinking about what it implies, quietly call it something else. The Great Nothing. And before you decide that a stretch of empty space sounds like the least interesting subject in the cosmos, I want you to hold on for just a moment. Because what this void actually represents, what it says about the structure of reality, about how the universe chose to arrange itself, and about what it would mean to be trapped inside, it goes far beyond empty space. This is one of the strangest objects in the known universe. It is bigger than most people are psychologically equipped to process. And the fact that it exists at all has implications that cosmologists have been quietly unsettled by for decades. Here's the first thing you need to understand. You've already been looking directly at it. Your entire life. Every time you've looked up at the night sky toward the north, you found the Big Dipper and traced the arc from its handle down to the brilliant reddish star Arcturus. The fourth brightest star, visible from Earth. You've been looking straight at it. Just past that point in the northern sky, right there in the constellation Boötes, sits a spherical region of space so empty, so devoid of matter, that it shouldn't exist. Not at this scale. Not by any straightforward reading of the physics. And yet, there it is. An absence so large it carved itself into the structure of the universe like a wound. Let's establish the scale before we go any further. Because the scale is where the first real discomfort begins. The Boötes Void sits approximately 700 million light-years from Earth. To understand what that distance means, consider that our closest major galactic neighbor, the Andromeda Galaxy, that faint smudge you can just barely resolve, on a clear night, sits 2.5 million light-years away. The Boötes Void is 280 times farther than that. If you could somehow travel at the speed of light, which remains physically impossible for anything with mass, the journey would take 700 million years. That is roughly how long it took animal life on Earth to develop from the first primitive multicellular organisms. Simple creatures barely more complex than sea sponges, all the way through the entire evolutionary chain. The first fish, the first land-dwelling creatures, the age of reptiles, the rise and extinction of the dinosaurs, the emergence of mammals, and eventually, after all of that, you. The entire arc of complex life on this planet would pass in the time it would take light itself to reach the edge of this void. With our fastest existing spacecraft, the Parker Solar Probe, which travels at roughly 0.05% of light speed, the trip would take over 1 trillion years. That number is not a rhetorical device. It is the actual mathematical result. 1 trillion years against a universe that is only 13.8 billion years old. The gap between those two numbers should feel wrong. It should feel like the universe is doing something it shouldn't be allowed to do. And in some sense, it is. But we're going there anyway. Not physically, that's permanently off the table, but mentally, conceptually, we're going to walk all the way to the center of this thing and stand inside it and look around. And what you find there is going to change the way you think about structure, about emptiness, and about what the universe actually looks like when no one is watching. Imagine you've left Earth. You've escaped the atmosphere, passed the moon, moved through the inner solar system. The planets thin out behind you. The sun shrinks to a point. You push past the outer planets, past the cold debris fields at the edge of the solar system, and eventually break free of the sun's gravitational influence entirely, crossing into true interstellar space. At this point, the sky above you is still brilliant. The Milky Way stretches across your entire field of view, like a river of light so dense and complex, it almost looks solid. You are not alone here. You are swimming in stars, hundreds of billions of them. Every direction you look, the galaxy surrounds you completely. Now you travel for a long time. You move outward from the galactic plane, climbing up out of the disk of stars. You start to see the full shape of our galaxy from the outside. A vast, slowly rotating spiral structure, lit from within, about 100,000 light-years across. Earth sits roughly halfway between the galactic center and the outer edge. To exit the galaxy from your starting point, even traveling in a straight line at near light speed, you'd spend roughly 26,000 years in transit. Just to get out. And then you do get out. And this is where the sky changes, in a way that's hard to fully describe without experiencing it. The dense star field disappears. Where there were hundreds of millions of individual stars visible in every direction, now there are almost none. The Milky Way is behind you, a glowing disk, still enormous, still gravitationally present, but no longer filling your sky. Instead, scattered across the dark, you see faint smudges of light, distant galaxies, other island universes, each containing hundreds of billions of their own stars, but so far away that they appear as nothing more than soft, hazy points in the black. You travel for a long time. The smudges of light thin out as you move away from the dense regions of our local galactic cluster. Millions of years pass. The familiar constellation of nearby galaxy clusters fades behind you. You pass through filaments, long, thread-like structures made of gravitationally bound galaxies and dark matter, and then you move through the spaces between them, the places where the filaments haven't reached. And the sky starts to go dark, in a way that feels different from ordinary space. Not just emptier. Wrong. The last galaxy clusters visible to your instruments are behind you now. Ahead, there is nothing. No smudges of light, no faint infrared signals, no radio emissions hinting at distant stars being born. Just a gradual, deepening darkness that, as you cross an invisible threshold, becomes absolute. You have entered the outer boundary of the Boötes Void, and you still have a very long way to go to reach the center. The Boötes Void is 330 million light-years across. That single dimension, its diameter, is already one of the most disturbing numbers in observational cosmology. Think about what that means structurally. If you placed our entire Milky Way galaxy inside the Boötes Void and started counting how many copies of the Milky Way you could fit inside it before you ran out of room, the answer runs into numbers so large, they stop feeling like quantities and start feeling like philosophical problems. The void is not a gap. It is not a thin region between two dense structures. It is a vast, spherical absence, roughly the size of, well, the size of a region that should, by the statistical expectations of cosmological models, contain thousands upon thousands of galaxy clusters, billions of individual galaxies, and hundreds of trillions of stars. Instead, it contains 60 galaxies, approximately 60 by the best current estimates, clustered together in a single thin filament stretching through the void's interior, surrounded on all sides by an emptiness that extends for tens of millions of light-years in every direction. 60 galaxies in a region that should hold thousands. If you wanted an analogy that preserved the ratio, imagine the entire Pacific Ocean, every cubic meter of it, from surface to trench, and then imagine it contains 60 goldfish. Spread across that entire volume, you would statistically never encounter one. They are as good as invisible, as good as not there. Now, you might wonder how we even found this place. How do you discover something defined entirely by absence? The story of the Boötes Void's discovery is itself quietly strange. It happened in 1981, when a team of astronomers, working to construct a three-dimensional map of the large-scale structure of the universe, cataloging the positions and redshifts of thousands of galaxies, noticed something. A region of the sky, in the direction of the Boötes constellation, was coming back empty. Not sparse, not underdense, empty. In a region where their models predicted they should be detecting dozens of galaxy clusters, the instruments found almost nothing. The lead astronomer on that survey, Robert Kirshner, described the discovery in terms that were careful and measured, but that carried underneath them a quality that astronomers rarely allow themselves genuine bewilderment. The void they'd found was, at the time, the largest known structure in the observable universe, and its size didn't fit comfortably into existing models of how cosmic structure was supposed to form. It was too big, too empty. The universe, according to the best physics of the time, should not have had enough time since the Big Bang to create a void of this magnitude. There simply hadn't been enough cosmic time for matter to migrate away from a region this large and leave it this clean. That problem, and it was a real problem, not a minor discrepancy, has since been partially addressed by refinements in cosmological models, by better understanding of dark matter and dark energy, and the large-scale web of structure in the universe. But the Boötes Void still sits at the outermost edge of what our models comfortably explain. It is, in a specific technical sense, larger than it should be. And there are cosmologists who still find that quietly troubling. Here's what the universe actually looks like, at the scale where voids become visible. Forget the idea of stars and galaxies distributed evenly across space like stars on a clear night. That image is wrong at every scale above the individual galaxy cluster. The real structure of the universe, when you pull back far enough to see it, looks like foam. Specifically, it looks like the foam that forms when you agitate soapy water, a network of thin walls and filaments surrounding empty spherical regions. The foam is called the cosmic web, and the bubbles inside it are the voids. Every void is a place where gravity has spent billions of years doing the opposite of what you might expect it to do. We tend to think of gravity as a force that pulls things together, and it does. But in the context of the cosmic web, gravity's relentless inward pull on the dense regions, the galactic walls, the superclusters, the filaments has the equal and opposite effect of emptying out the spaces between them. As matter flows toward the dense attractors, the voids between them become progressively emptier. Over 13.8 billion years of this process, the dense regions have become extraordinarily dense, and the voids have become extraordinarily empty. The universe has sorted itself into two completely different realms: the bright, chaotic, gravitationally active structures where galaxies and stars live, and the dark, cold, essentially static voids between them. Voids, by current estimates, make up approximately 80% of the total volume of the observable universe. Think about that proportion carefully. The overwhelming majority of space, by volume, is void. The galaxies and clusters and filaments that we observe when we look at the sky, all of that visible structure, all of that light and matter and activity occupies roughly 1/5 of the universe's total volume. Everything else is absence. The universe is, structurally, mostly nothing, and the Boötes Void is the largest known example of that nothing. When you reach the center of the Boötes Void, you are as far from any galaxy as it's physically possible to be in the known universe. The nearest galaxy, one of those 60 scattered in the void's interior, would be something like 10 million light-years away. A galaxy at that distance, even a large and luminous one, emits so little light by the time it reaches you that the human eye cannot detect it. To the unassisted human visual system, the center of the Boötes Void is completely dark. Not mostly dark, not dark with a few faint stars. Completely, absolutely, perfectly dark, in every direction simultaneously. There are no reference points, no light sources, no gravitational signatures from nearby mass. The temperature is approximately 3 degrees Kelvin, just barely above absolute zero. The ambient temperature of deep space, the residual thermal hiss of the Big Bang itself, faded almost completely to silence. This is not a metaphor. If you were physically present at the center of the Boötes Void, somehow kept alive in some sealed environment, and you turned off every artificial light source, you would experience complete darkness. Not the darkness of a room with the blinds closed, not the darkness of a cave. A darkness with no exceptions. A darkness in every direction for distances that exceed the human brain's ability to intuitively process. 165 million light-years of nothing in every direction from where you stand. There's a particular psychological effect that humans experience in conditions of complete sensory deprivation. The brain, deprived of input, begins to generate its own. Researchers who study sensory deprivation tanks, environments designed to eliminate as much external stimulation as possible, have documented predictable progressions. First, a deepening calm, then a heightened sensitivity to internal sensations, then, after a certain threshold, the slow emergence of internally generated perceptions. Sounds that aren't there, colors at the edges of vision, shapes in the dark. The brain, in the absence of external reality to process, starts constructing its own. In the center of the Boötes Void, that process would begin. and there would be nothing to interrupt it. No passing ship, no distant signal, no light, just the dark and the cold and the silence that has existed there, unbroken, for hundreds of millions of years. Hold on to that image. We'll come back to it. There is a question lurking beneath the surface of everything we've discussed so far. And it's the kind of question that sounds simple until you actually try to answer it. The question is this: why does the Boötes Void exist? Not in the general sense, we've touched on the mechanism of gravity and the formation of the cosmic web, but specifically, why is this void so large? Why, in this particular region of space, did matter so thoroughly abandon its post? The answer that modern cosmology provides is incomplete. It's honest about being incomplete, which in science is worth something. The standard model of cosmic structure formation, the framework we use to understand how matter organized itself after the Big Bang, does predict the formation of voids. It predicts a web-like large-scale structure. It predicts regions that are emptier than average. What it does not cleanly predict is a void of the Boötes Void size, at the density we observe, given the age of the universe. The numbers fit, but only barely. The Boötes Void sits right at the edge of what the standard model can accommodate without modification. Some cosmologists have proposed that the void might be a statistical outlier, a rare but theoretically possible fluctuation in the initial density field of the early universe, that over billions of years grew to produce a void of exceptional size. This explanation is technically valid. It doesn't violate any known laws of physics. But it requires the Boötes Void to be genuinely exceptional, not just the biggest void we found, but one of the most improbable structures in the observable universe, a cosmic accident of a scale that should make you at least pause. Others have suggested that the standard model might simply be missing something, that some physical process we haven't fully accounted for, some interaction between dark matter and dark energy, some relic feature of inflationary cosmology, might produce voids larger than our current models expect. The Boötes Void, in this reading, isn't an outlier. It's a clue, a gap in our understanding, made manifest as a gap in the universe itself. And then there are other proposals that live further from the mainstream, the ones that most working cosmologists would describe as speculative, but that haven't been formally eliminated. The most notable of these is the suggestion made seriously, in peer-reviewed literature, by researchers at legitimate institutions that the Boötes Void might be a supervoid created or affected by a cosmic scale collision, that at some point in the universe's history, two enormous voids merged, or that some gravitational event of titanic scale carved this region of space clean. The evidence for this remains thin, but the fact that it's being considered at all is a marker of how unusual the Boötes Void really is. There's something about the void that resists comfortable explanation. It's not that it breaks any known physics, it doesn't. It's that it sits at the edge of what our best models can explain. And it sits there with a kind of implacability that makes you feel, however irrationally, that the universe is being deliberately unhelpful, that it chose this particular corner of itself to be maximally strange. There is a parallel worth drawing here, one that might seem unrelated at first, but will matter more than it appears to right now. When astronomers first began mapping the large-scale structure of the universe in the late 1970s and early 1980s, they were not looking for voids. They were mapping the presence of matter. The absence was a byproduct of the survey, a ghost that appeared in the data when the expected signals simply weren't there. In that sense, the Boötes Void was not discovered. It was noticed. And there's a meaningful distinction between those two things. Discovery implies intent, direction, a hypothesis confirmed. Noticing is something different. It's the moment when the data refuses to behave, when the pattern you were looking for doesn't appear, and instead something else, something you had no framework for, reveals itself in the gap. The history of science is full of discoveries made this way, in the negative space of an experiment, in the failure of an observation to return the expected result. The most unsettling things we know about the universe have almost always arrived first as absences, as questions, not answers. As something wrong in the data, the Boötes Void arrived that way. And it has remained, in some sense, a question, rather than an answer ever since. Consider what it means for a region of space 330 million light-years, across to be essentially empty. Not empty in the local sense, not the relative emptiness between stars, or even between galaxies. Empty at the scale of galactic superclusters. To give you a structural comparison, the Virgo supercluster, the large-scale structure that our own Milky Way is part of, is roughly 110 million light-years across, and contains hundreds of galaxies, including our own local group, and dozens of other clusters. The Boötes Void is 3 times the diameter of the Virgo supercluster, and while the Virgo supercluster is filled with hundreds of galaxies and billions of stars and planets, the Boötes Void contains, in a space 3 times larger, 60 lonely galaxies, in a void where hundreds of thousands should be. The cosmic web, that structure of filaments and walls and voids that describes the universe at the largest scales, is not uniform. It has regions of extraordinary density, where galaxy clusters pile on top of galaxy clusters in gravitational tangles of unimaginable complexity. It has moderate regions, average regions, regions that look more or less like what the statistical models predict. And then it has outliers, places that fall far outside the expected distribution. The Boötes Void is the most extreme outlier on the empty side of the spectrum that we have found. It is not just the largest void. It is the clearest, most dramatic example we have of the universe's capacity for absolute emptiness on a scale that defies comfortable intuition. And here is something that very few people think about when they think about voids. They are not static. The Boötes Void is not simply sitting there, unchanged, a permanent feature of the universe's geography. It is growing, slowly, by cosmic standards, but growing nonetheless. The mechanism is the same one that created it in the first place: gravity. The dense regions at the edges of the void, the filaments and walls and galaxy clusters that define its boundaries, continue to exert gravitational attraction on the sparse matter inside the void. That matter, what little there is, continues to be slowly drawn outward toward those dense regions, further emptying the void's interior. At the same time, the expansion of the universe itself, driven by dark energy, the mysterious force that is causing the universe's expansion to accelerate, rather than slow, pushes the void's boundaries further apart. The void grows from inside as matter drains out, and from outside as the universe expands around it. The great nothing is getting greater. In a billion years, the Boötes Void will be emptier than it is now. Those 60 galaxies in its interior filament, already impossibly isolated, already separated from each other by distances that dwarf the span of our entire local supercluster, will have drifted further still toward the void's edges, or further apart from each other. Depending on their individual trajectories, the interior will become cleaner, more absolute. The darkness will deepen. In 10 billion years, in the far future of a universe increasingly dominated by dark energy and the accelerating separation of all things from all other things, voids like the Boötes Void will represent the default state of the universe, not the exception, the rule. The dense regions, the clusters and filaments, will still exist. Gravity is strong enough, at small enough scales, to hold those structures together indefinitely. But the vast majority of the universe's volume will be voids, will be nothing. The cosmic web will remain, but it will be stretched thinner and thinner, its nodes holding together, while the spaces between them grow enormous, beyond any current scale of reference. This is where things stop making ordinary sense, and I want you to sit with the implication for a moment before we move on. The universe that future civilizations, if any exist, will observe from inside any galaxy will look radically different from the universe we observe today. Today, we can see billions of galaxies distributed across the observable universe. We can detect the cosmic microwave background radiation, the afterglow of the Big Bang itself, still present and detectable in every direction. We have access to an enormous amount of evidence about the origin, structure, and evolution of the cosmos. But in the far future, as the universe expands, and the distances between galaxy clusters grow beyond the limits of light to ever bridge them, most of those distant galaxies will have crossed the cosmological horizon. They will be moving away from us faster than light can carry their image back. They will become, for all practical observational purposes, non-existent. Future civilizations, if they exist in 100 billion years, will live in a universe that appears, from their vantage point, to contain only their local galaxy or galaxy cluster. The rest of the universe will be dark, invisible, gone. Not actually gone, still there, still populated with matter and stars and perhaps life, but separated by distances so vast that no physical connection between them is possible. Each island of matter will be alone in a sea of void so large that no instrument could ever reach across it. From inside the Boötes Void, that future has already arrived. Whatever civilization might theoretically exist in one of those 60 galaxies, and the probability is staggeringly low, but it is not zero, would already live in a universe that looks, from their position, almost completely empty. They would see, if their instruments were sufficiently powerful, the faint signatures of the galactic walls far beyond their void's edges. But those walls would be tens of millions of light years away. For the most distant of them, the separation would be great enough that no signal sent today would ever arrive. No communication possible, no visitation, no confirmation that the universe beyond their void even contains anything at all. They would be, in the most literal sense imaginable, alone. This is worth holding, because it does something to the concept of isolation that is worth examining. We use the word alone in human contexts to mean separated from other people, separated from community, from connection, from the web of relationships that structures human experience. The aloneness of the Boötes Void is of a categorically different order. It is not social isolation. It is physical isolation at a scale where the very concept of proximity ceases to be meaningful. In the center of the Boötes Void, the nearest galaxy is not close enough to visit, not close enough to observe with the naked eye, not close enough to influence in any physical way. It is simply there, as a mathematical fact, as a distant gravitational presence too faint to register on any human scale instrument. The isolation is total. The aloneness is structural, woven into the geometry of the space itself. And yet, and this is important, the void is not dead. It is not inert. The laws of physics operate there, exactly as they operate here, in our densely populated corner of the cosmic web. Quantum fields vibrate through the void. Virtual particles pop briefly into existence and annihilate each other in the vacuum energy that persists everywhere in the universe, even in the most empty regions. The cosmic microwave background radiation, that 2.7 Kelvin whisper of the Big Bang, fills the void as it fills all of space. Dark matter, the invisible mass that doesn't interact with light, but does interact gravitationally, likely threads through the void in some form, though at densities far below what we find in the cosmic web's populated regions. The void is not nothing in the absolute philosophical sense. It is a near nothing, a space maximally depleted of the ordinary matter and energy that we typically mean when we say something exists. But the substrate of physics, the fields, the quantum vacuum, the fabric of space-time itself, persists even there. The laws that govern the behavior of everything persist there. If you dropped an electron into the center of the Boötes Void, it would behave exactly the way an electron behaves here. It would spin, it would carry charge, it would interact with the quantum vacuum, it would obey every rule that electrons obey everywhere. The void is empty of content. It is not empty of law. There is something about that distinction that I find genuinely unsettling, in a way that's hard to fully articulate. The persistence of physical law in a space utterly devoid of matter to apply those laws to. Rules without a game. Grammar without words. Structure without substance. The universe, in the Boötes Void, keeps all its machinery running in perfect order, and there is nothing there to be ordered. The apparatus of reality operates in complete, patient darkness, waiting for matter to arrive that never will. We should talk, at some point, about what it would actually feel like. Not the physics, not the cosmology, but the phenomenology. What it would mean, in any experiential sense, to be inside that space. Because the human response to radical emptiness is not neutral. We are creatures of presence. Our nervous systems evolved in an environment densely packed with stimuli, light, sound, movement, other organisms, gravitational orientation, temperature gradients. We are built, at a very deep level, to process a world full of things. Deprive us of those things systematically, and something predictable happens. The research on extreme isolation is unambiguous on this point. Humans placed in conditions of significant sensory reduction flotation tanks, dark rooms, polar winter stations experience predictable cognitive and perceptual changes. The timeline varies by individual and by the degree of deprivation, but the general arc is consistent. First, there is often a period of calm, even pleasure, the relief of not being overwhelmed by constant input. Then, as the deprivation extends, the brain begins to compensate. It generates its own signals to fill the deficit. Auditory hallucinations are common. Visual phenomena appear at the edges of perception: colors, shapes, movement in the dark. The sense of self, which is anchored in large part by sensory input from the environment, begins to feel less solid, less reliable. Questions that normally don't surface about where the body ends and the environment begins, about the stability of memory and identity, start to press upward from wherever they're usually kept. In conditions of prolonged, total darkness and silence, these effects become profound. People report experiences that are difficult to categorize states of consciousness, that don't map onto ordinary waking experience or sleep. Some describe them as peaceful. Some describe them as terrifying. Many describe them as both, at different times, sometimes in rapid alternation. Now transpose that onto the center of the Boötes Void. Complete darkness in every direction. No sound. Space is a vacuum. Sound doesn't propagate. No gravitational orientation. You'd be in freefall, with no planetary surface to tell you which direction is down. No stars to anchor your sense of position and direction. No movement you could detect without instruments. Just the absolute cold 3 degrees above absolute zero, held at bay by whatever environment you're in. The sensory deprivation in that environment would be as close to total as physics allows. Not because the void has done anything to you, simply because there is nothing there. What happens to a mind in that condition, over time, is a question that has no empirical answer, because no human has ever been there. But the directional indicators from isolation research suggest a progression that is, at minimum, deeply disorienting, and at maximum, something more fundamental than ordinary psychological distress. The mind's capacity to maintain a stable model of reality depends, more than we normally acknowledge, on continuous grounding in sensory contact with the external world. Remove that grounding completely, remove it for long enough, and the model starts to drift. This becomes important later. For now, let's stay with the scale. Because there is one more dimension of the Boötes Void's size that we haven't fully confronted yet, and it's the one that, for me, produces the deepest response. It's not the diameter. It's not the count of absent galaxies. It's the travel time. Even at the speed of light, the absolute speed limit of the universe, the fastest anything can possibly move crossing the Boötes Void from edge to edge, would take 330 million years. From the edge to the center, 165 million years. 165 million years of unbroken light-speed travel through complete darkness, and you would arrive not at the other side, not at a destination, but at the midpoint of the void. You would be exactly as far from the edge behind you as from the edge ahead of you, equidistant from everything, maximally isolated. 165 million years of light-speed travel. Let's hold that number in context. 165 million years ago, on Earth, the Jurassic period was drawing toward its close. Dinosaurs were the dominant terrestrial vertebrates. The first small mammals had recently evolved. The continents were arranged in configurations that would be unrecognizable today. The Atlantic Ocean had only recently begun to form, as the supercontinent Pangaea completed its fracturing. The Himalayas did not exist. The Rocky Mountains did not exist. The Amazon basin was not yet a basin. 165 million years of Earth's geological and biological history, compressed into the duration it would take light to travel from the Boötes Void's edge to its center. And then you'd be there, in the dark, exactly as far from everything as it's possible to be. There is a specific kind of terror that has no object. Most fear is directional. It points at something. A predator, a height, a social threat. The nervous system identifies a source and orients the body toward it, preparing for response. That fear, however uncomfortable, is functional. It has structure. It tells you where to look. The terror of the Boötes Void, if you were to genuinely sit inside it in your mind and take it seriously, is of a different order. It has no object. There is nothing there to be afraid of. No predator, no fall, no threat. Just the absence of everything that normally structures the experience of being somewhere. And the human nervous system, confronted with that kind of featureless emptiness at sufficient scale, does not respond with calm. It responds with a particular category of unease that philosophers have sometimes called the sublime. That specific feeling, produced by encountering something so large, so indifferent, so completely beyond the scale of human significance, that the mind briefly loses its footing. We tend to romanticize the sublime. We put it in paintings of mountains and stormy seas. We treat it as an aesthetic experience, something to be sought and savored. But the original theorists of the sublime were more honest about what it actually contains. It is not purely pleasant. At its core, the sublime is the feeling of being confronted with something that makes you small in a way that cannot be resolved. That doesn't go away when you turn from the mountain or step back from the cliff's edge. The Boötes Void, fully apprehended, produces that feeling and then refuses to let it resolve, because there is no turning away from it. Even from Earth, 700 million light years away, it is there in the direction of Boötes, in the space between the Big Dipper and Arcturus, sitting in the sky above you at this very moment, patient and enormous, and completely indifferent to your existence. Most of the universe is indifferent to your existence, of course. That's not a controversial claim, but the Boötes Void makes the indifference structural in a way that other regions of the cosmos don't quite manage. Other regions of the universe are at least full of things. Stars being born, galaxies colliding, planets forming. The indifference of a star to any individual human life is total. But the star is at least doing something. It is burning, fusing hydrogen into helium, producing light and heat and the heavy elements that will eventually seed new solar systems. The indifference is productive. The Boötes Void is indifferent and empty and utterly still. 330 million light years of space, and nothing in it worth watching, or almost nothing. We mentioned earlier that the void contains approximately 60 galaxies, clustered in a thin filament running through its interior. Let's spend a moment with those galaxies, because they are among the most isolated objects in the known universe, and the implications of their isolation are, in a quiet way, among the most extraordinary things about the Boötes Void. Each of those 60 galaxies is, individually, an enormous structure. A typical galaxy contains anywhere from a few hundred million to several trillion stars. Even a small, irregular dwarf galaxy, the kind most likely to be found in a sparse environment, like the interior of a large void, contains hundreds of millions of stars, and almost certainly many of those stars host planetary systems. The filament running through the Boötes Void is not, in itself, remarkable. It looks like a small, thin piece of the same cosmic web structure that organizes matter everywhere else. It simply has the distinction of being located in the middle of the most dramatically empty region of space that we know exists. Those galaxies are aware of each other, gravitationally speaking. They exert tidal forces on each other. They are, at the largest scales, in motion relative to each other, either slowly approaching or slowly separating, depending on their individual velocities and the local gravitational dynamics. They have a relationship with each other, in the sense that their mutual gravitational interaction shapes their evolution, their structure, their star formation rates, but they have essentially no relationship with anything else. The nearest galaxy outside the void is tens of millions of light years away. Even by the standards of intergalactic distances, which are already vast, that separation is extreme. A signal sent from one of those 60 galaxies, at the speed of light, aimed at the nearest galaxy beyond the void's edge, would travel for tens of millions of years before arriving. No information about what is happening in those galaxies reaches us in anything like real time. What we observe when we detect them, if we can detect them at all, given the distance, is a snapshot from the deep past. We are not seeing those galaxies as they are. We are seeing them as they were, when the light that is only now reaching us first left their stars. This is always true of astronomical observation, of course. Every star in our night sky is a point of light from the past. The sun we see is 8 minutes old by the time its light reaches our eyes. The nearest star, Proxima Centauri, shows us light that is 4 years old. The Andromeda Galaxy presents itself to us as it was 2.5 million years ago. But for the galaxies in the Boötes Void, the delay is so extreme that the concept of simultaneous observation becomes essentially meaningless. We are seeing them as they were across a span of time so large that entire galactic evolutionary cycles, the birth, main sequence life, and death of stellar populations can occur within the light travel delay. Now here is a thought that should sit uncomfortably. Those galaxies are, statistically, likely to have planets. Many of those planets, over the billions of years those galaxies have existed, may have developed conditions suitable for chemistry, for geology, for the emergence of self-replicating molecules, for life. We have no evidence of this. We have no way to get evidence of this. The distances involved make any form of observation of individual planets in those galaxies physically impossible, now or in any foreseeable future. But the statistics of planetary formation in galaxies suggest that planets are common. And the statistics of life, though, we have only one confirmed data point, which is both encouraging and methodologically problematic, suggest at minimum that life is possible wherever the conditions are right. If life has developed in one of those 60 galaxies, it has developed in the most isolated environment in the known universe. Any civilization that has arisen inside the Boötes Void has done so surrounded, on all sides, by an emptiness that extends further than the light travel time since the Big Bang, in every direction without exception. They would look at their sky, assuming they have eyes, assuming they look at skies, which is a great deal to assume, and see a very small number of galaxies in their immediate filament. And then, in every other direction, nothing. Not thin, not sparse, nothing. The concept of the cosmic web might be entirely unavailable to them if their observational technology developed before their civilization could detect the faint signatures of matter at the void's distant edges. And here is the part that carries weight. If such a civilization exists, if it developed science, if it developed cosmology, if it looked at the universe and tried to understand its structure, it would reach conclusions about the nature of the cosmos that are fundamentally different from the conclusions we have reached. It might conclude that the universe is composed of a small, finite number of galaxies in a vast, mostly empty sea. It might develop entire cosmological frameworks built around the assumption that matter is sparse and widely distributed, rather than organized into the dense filaments and walls that characterize the observable universe from our position. It might, with great effort and rigor and intelligence, construct a complete and internally consistent model of the cosmos that is wrong in its most fundamental premises, not because of any failure of intelligence or method, but because of where it is, because its window onto the universe is the Boötes Void, and the Boötes Void shows almost nothing of the universe's actual structure. This is a thought worth sitting with. How much of what we believe about the universe is a function of where we are inside it? We occupy a specific location inside a spiral galaxy, in a modest galaxy cluster, embedded in a supercluster, positioned on the cosmic web in a region of average density. Our cosmological models are built on observations made from this position. We have corrected, to the best of our ability, for local biases. We have developed frameworks for understanding large-scale structure that we believe are valid across the observable universe. But the assumption underlying all of that is that our position, while specific, is not so unusual that it gives us a systematically distorted view, that we are sampling the universe fairly. The Boötes Void is a reminder that some positions are not fair samples. Some positions in the universe give you a view so systematically skewed that correct conclusions may be inaccessible from that vantage point. It doesn't prove that our own position is similarly distorted, but it demonstrates that the universe contains such positions, that the cosmos, in its indifference, does not distribute perspectives fairly. Some observers get the cosmic web, some observers get the void, and we do not know, from first principles, which kind we are. Let's return to you, floating in the center of the Boötes Void, in your sealed environment, in the total dark, in the cold. We've established the physical conditions. We've talked about the sensory deprivation, the cognitive drift, the particular quality of darkness that has no exception in any direction. But there is something we haven't yet addressed about that experience, something that becomes relevant after the initial disorientation passes, if it passes, and you begin to orient toward the longer duration of being there. There is a gravitational quality to time in the void. Not literally, gravity is nearly absent there, which is part of the point, but experientially. In an environment with no external reference points, time itself becomes strange. Our ordinary sense of time passing is anchored in change. Day and night, the rhythm of meals and sleep, the movement of other people, the sequence of events, the progress of projects and conversations. Strip those anchors away, and the internal sense of duration becomes unreliable. Isolated subjects report that time seems to both expand and compress, unpredictably. Minutes can feel like hours. Hours can seem to vanish. The sense of narrative continuity, the feeling that time is moving in a coherent sequence, from a past through a present, toward a future, begins to loosen. In the center of the Boötes Void, there is no day and night. There is no external change of any kind. There is only the dark and the cold and the hum of whatever life support system your environment maintains. Time, in that context, would become entirely internal, entirely constructed from biological rhythms and memory and the machinery of subjective experience. And over long enough durations, that internal clock drifts. It doesn't stop. The circadian rhythm is robust enough to persist, even in total isolation, but it loses its relationship to any external standard. It becomes a clock that runs without reference to anything outside itself. This is the precise opposite of how cosmological time works. The universe has extremely good clocks. The expansion rate of the universe, the decay of radioactive isotopes, the rotation periods of pulsars, the cooling of white dwarf stars, all of these are clocks of extraordinary precision anchored in physical law, consistent and verifiable. The universe's time is objective in a way that makes human subjective time look like a rough approximation at best. But inside the Boötes Void, in total isolation, the gap between those two kinds of time, the precise, externally anchored cosmic time, and the drifting, internally constructed human time would become maximally apparent. The universe would be keeping its time with perfect fidelity. You would be keeping yours with increasing uncertainty. After long enough, the question of when you are would become genuinely difficult to answer. Not just imprecise, genuinely uncertain in a way that would have practical consequences. Has it been 3 days? 3 weeks? The body keeps rough count, but without external cues, the count drifts. After months, the drift becomes significant. After a year, you might not know the year. After a decade, you might not know the decade. And in the center of the Boötes Void, there is nothing. No stellar position, no seasonal change, no social reference that could correct that drift. You would age in a darkness that tells you nothing about how long you've been aging. The philosophers who think seriously about personal identity over time, about what makes you the same person at 40 that you were at 10, might note that continuity of memory is usually considered central to that, persistence. You are the same person in part because you remember being the younger version, and those memories form a chain that connects your present self to your past. But memory is itself reconstructive and fallible. Under conditions of prolonged isolation, memory becomes less reliable. The chain develops gaps. The gaps create uncertainty about the sequence of events, about what happened and when, about which memories are genuine and which are confabulated by a brain trying to maintain coherence against insufficient evidence. In the Boötes Void, those conditions are maximized, and what they point toward, at the extreme end, is a kind of self-dissolution that has nothing to do with physical death. The body would persist. The brain would continue functioning, but the constructed narrative of identity, the story you tell yourself about who you are, where you came from, what you've experienced, would become progressively less reliable, less anchored, less continuous. You would remain biologically alive, while the particular configuration of memories and self-model that constitutes your identity would slowly become something else, something that had grown in the dark, without reference to anything outside itself, without the constant corrective pressure of external reality pushing back against its drift. This is not a metaphor. This is a description of what prolonged, complete isolation does to human psychology, taken to its logical extreme. The Boötes Void simply provides the most extreme environment in which it could occur. Hold on to this. Because there's a parallel in the void itself that we haven't drawn yet, and it connects to something larger. The universe, in its earliest moments, in the first fractions of a second after the Big Bang, was a state of near-perfect uniformity. The matter and energy distributed through that early universe was almost, but not quite, evenly spread. The fluctuations were tiny, fractional. The differences in density from one region to another were so small that they would be invisible to any instrument that wasn't extraordinarily sensitive. But those tiny fluctuations, those almost imperceptible seeds of unevenness, were the origin of everything. Every galaxy, every star, every planet, every ocean, every living thing, every thought that has ever been thought in the history of the cosmos, traces back to those initial fluctuations in density. The dense regions became denser. Gravity pulled matter toward the already slightly denser regions and away from the already slightly emptier regions. Over hundreds of millions of years, the slight difference is amplified. The dense regions became galaxy clusters. The empty regions became voids. The cosmic web emerged from what had been nearly featureless uniformity. The Boötes Void is, in this sense, the direct inverse of the most complex structures in the universe. Where a galaxy cluster represents the maximum local concentration of matter, the end point of billions of years, of gravitational amplification of an initial density surplus, the Boötes Void represents the maximum local depletion, the end point of billions of years of gravitational evacuation of an S0, initial density deficit. They are both extreme products of the same fundamental process. The same force that built the most complex structures in the universe also built the most empty region we have ever found. There is something almost dialectical about that. The universe's creative process and its emptying process are not separate. They are the same process, viewed from different positions. Every galaxy that coalesced, every supercluster that formed, every filament that thickened and brightened each of those events was simultaneously an emptying. The matter that went into the filaments came from somewhere. It came from the voids. The construction of the cosmic web and the excavation of the voids are two descriptions of the same event. Matter moving through space under the influence of gravity, leaving some regions full and others empty. The Boötes Void is not an absence from the universe. It is a consequence of the universe. It is the shadow cast by structure, the dark produced by light, and it is 330 million light-years across. Now there is a question that has been building since the beginning of this, and it's time to approach it directly. We've been describing the Boötes Void as the largest known void in the universe. But what does known mean? In this context, it means the largest void that we have detected within the observable universe. The observable universe is the region of space from which light has had time, since the Big Bang, to reach us. It has a radius of approximately 46 billion light-years in every direction. Everything within that sphere is, in principle, observable to us. Though in practice, our surveys cover only portions of it, and only to certain depths and sensitivities. Beyond the observable universe, there is more universe, almost certainly more. The total extent of the universe, the full, complete cosmos, not just the portion bounded by our observational horizon, is unknown. It may be finite or infinite. Current models of inflation, the period of extremely rapid expansion in the universe's earliest moments, suggest that the total universe is far larger than the observable portion. How much larger depends on the model, but estimates range from many times larger to incomprehensibly, unimaginably, infinitely larger. Some inflationary models suggest that the observable universe is a negligibly small fraction of the total. If that's true, and we cannot currently confirm or disprove it, then the observable universe, with its estimated 2 trillion galaxies and its hundreds of billions of light-years of structure, is itself embedded in a larger universe we cannot see. A universe that may contain voids larger than the Boötes Void, filaments more massive than anything in our observable sphere, structures of a scale that we have no data about and no observational access to. The Boötes Void is the largest void we know about. It may not be the largest void that exists, This is not a comfortable thought, but it is an honest one. The limits of our observation are not the limits of reality. The edge of the observable universe is not a wall. It is a horizon, a distance beyond which light hasn't had time to reach us, not a distance beyond which nothing exists. And horizons, by their nature, conceal more than they reveal. What lies beyond the Boötes Void's region of space, in the unobservable reaches beyond our cosmic horizon, is genuinely unknown. It could be more filaments and clusters, consistent with the cosmic web structure we observe within our sphere. It could be regions of space emptier or denser than anything within our observable universe. It could be regions where the physical constants themselves are different, a possibility raised by certain versions of inflationary theory, in which different regions of the universe underwent different inflationary histories and ended up with different low-energy physics. We don't know. We can't know with any current or foreseeable technology. The Boötes Void sits near the edge of what we can observe, and beyond it, the universe continues in silence. There is one more thing we should discuss before this part closes, and it concerns dark energy, the mysterious component of the universe that makes up approximately 68% of its total energy content, and is responsible for the accelerating expansion of the universe. We've mentioned it in passing, but its relationship to the Boötes Void is worth examining in more depth because it connects the void to one of the most consequential and least understood features of cosmological reality. Dark energy was discovered, or rather, its effects were first measured in 1998 when two independent teams of astronomers studying distant, type Ia supernovae, found that those supernovae were dimmer than expected. Dimmer than expected meant further away than expected. Further away than expected meant the universe was not just expanding, it was expanding faster than it had been expanding in the past. The expansion was accelerating. Something was pushing the universe apart, overcoming the decelerating effect of gravity on the largest scales. That something was called dark energy. We do not know what it is. We know its effects. We know that it behaves, mathematically, like a constant energy density inherent to empty space, the same everywhere, unchanging over time, always pushing outward. We know it currently dominates the universe's energy budget. We do not know its physical origin, its relationship to quantum field theory, where predictions about vacuum energy famously disagree with observations by a factor of 10 to the power of 120, the largest discrepancy in the history of physics, or whether it is truly constant or might change over time. What dark energy means for the Boötes Void is this. The void is not just a product of the past. It is an environment actively shaped by dark energy's continuous pressure. In a universe without dark energy, the expansion would be decelerating, and voids would grow more slowly as the overall rate of expansion slowed. In our universe, with accelerating expansion, voids grow faster. The boundary between the Boötes Void and the surrounding cosmic web is being pushed outward by the accelerating expansion of space itself. The void is, in some sense, the universe's most visible signature of dark energy's dominance. In the regions where matter is sparse enough that gravity can't counteract dark energy's expansive push, dark energy wins. The void grows. And dark energy will keep winning. Over the very long term, over timescales measured in tens and hundreds of billions of years, dark energy will cause the expansion of the universe to accelerate without limit. Galaxy clusters will remain gravitationally bound to each other, because gravity is strong at those scales. But the space between clusters will expand at an ever-increasing rate, eventually reaching the point where neighboring clusters are receding from each other faster than light speed, not violating relativity, which permits space itself to expand faster than light, only prohibiting objects from moving through space faster than light, and their light will never reach each other again. In that far future, every galaxy cluster will be its own observable universe, an island in a sea of expansion so rapid that no information can cross it. Every galaxy cluster will be, effectively, inside its own Boötes Void. The isolation that makes the void so remarkable today will be the default condition of every structure in the universe in the far future. What the Boötes Void is now, the universe will become. This is not speculation. It is the straightforward extrapolation of the physics we currently understand, applied to the timeline of a universe dominated by dark energy. The Boötes Void is not an anomaly in the universe's long-term trajectory. It is a preview of it, a region that has arrived early, at the condition the entire universe is slowly moving toward. Standing in the center of the Boötes Void, you would not be experiencing something alien to the universe. You would be experiencing the universe's future. The darkness you'd be surrounded by, the isolation that would extend in every direction for distances that light cannot quickly bridge, that darkness is where everything is going. Not for billions of years, not for the foreseeable future of any human civilization, but going there nonetheless. The universe is cooling and emptying and expanding toward a state that the Boötes Void already inhabits. The Great Nothing is not an exception. It is an early arrival, and that thought that we live in a universe structured such that its largest, emptiest regions are prefigurations of its ultimate state deserves more attention than it usually gets. We tend to think of the cosmic web, of the filaments and clusters and superclusters, as the universe's defining feature, as what the universe is. But that structure is temporary. It is a phase, a relatively brief episode in the universe's 8 billion year history, during which gravity has organized matter into complex, luminous structures that will, in time, be swallowed by the expansion of dark energy-dominated space. The Boötes Void is what persists, what lasts, what the universe defaults to when the transient drama of structure formation has played itself out. The stars will burn out. The black holes will eventually evaporate in the incomprehensibly distant future through Hawking radiation. The last structures will dissolve, and the universe will be, in every direction, what the Boötes Void is now. This is where things stop making sense in a comfortable way. And it's also where the most interesting questions begin. But we should be precise about what kind of sense it stops making. It doesn't stop making mathematical sense. The equations hold, the physics is internally consistent. The predictions of dark energy's long-term dominance follow logically from the observational data and the theoretical framework that has been refined over decades of careful work by thousands of researchers. It stops making intuitive sense. It stops making sense in the way that human minds evolved for the management of social relationships and the navigation of savanna-scale environments and the tracking of prey across distances measured in kilometers. Not light years process information about existence and time and structure. We are not well designed, cognitively, for cosmology. We are designed for the middle scales of reality, for the range of sizes between a bacterium and a mountain, for the range of times between a heartbeat and a human lifetime. The universe operates at scales that are so far outside those ranges in both directions, both enormously larger and incomprehensibly smaller, that our intuitions are not just unreliable guides. They are actively misleading. The universe does not care whether we find it comprehensible. It does not scale itself to human understanding. It is what it is, at the sizes it is, on the timescales it operates, regardless of whether those facts feel tractable to a 3-pound organ that evolved over a few million years on a mid-sized rocky planet in an ordinary spiral galaxy. The Boötes Void is one of the clearest demonstrations of that indifference. It is not trying to be incomprehensible. It is simply doing what gravity and dark energy and the initial conditions of the Big Bang dictated that it do. It is following the rules. And the rules, applied at sufficient scale and over sufficient time, produce something that the human mind encounters as a kind of conceptual vertigo, a void 330 million light-years across, growing, patient, dark, and precisely as it should be. Hold on to that, because the final part of this will take all of what we've covered, the scale, the isolation, the psychological dissolution, the deep time, the dark energy future, and pull them towards something that has been sitting beneath the surface of this entire conversation, waiting. A question about what the existence of the Boötes Void implies about the relationship between observers and the cosmos they inhabit, about what it means that reality, at its largest scale, is mostly nothing, and about why that nothing is, in its own way, the most important thing in the universe. There is a question in philosophy of science that sounds technical, but is actually deeply personal once you follow it far enough. The question is this: does the universe exist independently of being observed? Or does observation, perception, measurement, the registration of physical events by some kind of information processing system, play a constitutive role in what we mean when we say something exists? Most working scientists treat this as a settled question and a distraction. The universe existed before life, they say, correctly. It will exist after life. Stars were born and died for billions of years before any eye opened to see them. The cosmic web formed in the dark, without witnesses. The Boötes Void emptied itself across hundreds of millions of years, with nothing inside it capable of registering its own emptiness. The universe does not require an audience. This is true, but it is not the whole truth. And the Boötes Void, of all places in the cosmos, is where the part that isn't the whole truth becomes most visible. Consider what we mean when we say the Boötes Void exists. We mean that we have observational evidence, redshift surveys, galaxy catalogs, the mapped absence of expected signals, that a region of space in the direction of the Boötes constellation, approximately 700 million light-years away, is extraordinarily empty. We have not been there. No instrument we have built has been there. The light that carries our information about that region left it hundreds of millions of years ago. What the Boötes Void is right now, in this moment, as you process these words, that is not something we know. We know what it was. We have a description of its past, delivered to us at the speed of light, interpreted through instruments and models, and the assumptions baked into our cosmological framework. The Boötes Void, as it currently exists in the present moment, whatever that means across a distance of 700 million light-years, across which the concept of simultaneity becomes physically undefined, is in a very real sense inaccessible to us. Not just unexplored. Inaccessible in principle, under current physics, forever. The information about what it is right now will not reach us for another 700 million years, by which point the Earth will be gone, the Sun will be nearing the end of its life, and whatever passes for civilization on this planet, if anything does, will bear no resemblance to what exists today. The void exists. We do not doubt that. But our relationship to its existence is mediated entirely by ancient light, by instruments with finite resolution, by theoretical frameworks that are our best current approximations to truth rather than truth itself. We know the Boötes Void, the way you might know a place you've only ever seen in photographs taken before you were born. You can describe it, you can reason about it, but the living thing, the actual void, in its actual present state, is not available to you. This is true of everything in astronomy, of course. Every observation is an observation of the past, but the Boötes Void makes the point most dramatically because its distance and its emptiness combine to produce a kind of double inaccessibility. It is far enough that the light delay is geologically significant, and it is empty enough that there is very little light coming from it in the first place. The signal is old, and it is faint. The void communicates with us only through what barely escapes its edges, and what reaches us from those edges is already ancient history when it arrives. What this means, in a stripped-down way, is that the universe contains regions that are effectively beyond the reach of knowledge. Not beyond the reach of theory. We can describe the Boötes Void mathematically. We can make predictions about its evolution. We can situate it in the broader context of cosmological structure, but beyond the reach of direct empirical contact, beyond the point where observation can do more than extrapolate from inference. And if the universe is as large as inflationary cosmology suggests, if the observable universe is a tiny fraction of the total, then the regions beyond our horizon, the regions from which light has not yet had time to reach us, represent an incomprehensibly larger domain of the same inaccessibility. The Boötes Void is, in this reading, not an edge case. It is a mild example of a pervasive feature of the cosmos, the existence of reality at scales and distances that permanently exceed the grasp of any embedded observer. The universe is mostly beyond knowing from any fixed vantage point within it. There are scientists, careful, rigorous people, not prone to mysticism, who find this fact about the universe quietly extraordinary, not because it suggests anything supernatural, but because it means that the universe's full reality is, in a specific technical sense, larger than any account of it that any observer could ever produce. Every cosmological model, however accurate, is a model of the observable universe, not the universe. Every map is a map of what light has had time to deliver. The territory extends, in all directions, beyond what any map can capture. The Boötes Void sits near the boundary of what we can access. It is close enough to observe barely, at its extremes, but far enough and empty enough that what we observe is incomplete, aged, and mediated. It is a place about which we can speak, but cannot know directly. And in the void's interior, in the silence of its center, our words and instruments and models make no contact with anything at all. Let's bring this back to the human scale. Not because the human scale is what matters cosmologically, it doesn't, by any measure, but because it's the scale at which meaning is constructed, and meaning is what makes the difference between a number and an experience. You are made of matter that was once part of a star. This is not metaphor. The carbon in your body, the oxygen in your lungs, the iron in your blood, these elements were synthesized in stellar interiors over billions of years of nuclear fusion, and then dispersed into the interstellar medium when those stars died, and then gravitationally assembled into the solar nebula that collapsed to form the sun and its planets, and then chemically and biologically reorganized over billions of years of planetary and evolutionary history into the pattern of atoms that constitutes you. You are, in a precise material sense, a temporary local organization of matter that was once dispersed across interstellar space. And you are, right now, on a planet inside a galaxy that is part of a supercluster, that is part of the cosmic web. You are embedded in structure. You are surrounded, at scales from the subatomic to the galactic, by organized, interacting, causally connected matter. The atoms in your body interact with each other through electromagnetic force. The cells in your body interact through biochemical signaling. Your body interacts with its environment through sense and motion. Your mind interacts with other minds through language and behavior. Your civilization interacts with its cosmic environment through observation and inference. You are, at every scale, woven into relationship, connected, part of the web. The center of the Boötes Void is the universe's most extreme alternative to that condition. It is the point of maximum disconnection. The place where the web has drawn back completely and left a space in which nothing is causally connected to anything nearby, because there is nothing nearby. It is the universe's answer to the question, what does it look like when there are no relationships? When there is no web? When every scale, from the astronomical to the human to the subatomic vacuum energy of space itself, has been stripped of the organized complexity that makes one thing interact meaningfully with another. It looks like the Boötes Void. It looks like darkness in every direction. It looks like nothing for 165 million light years. And in some way, that is difficult to articulate without becoming imprecise. The existence of that emptiness makes the existence of structure more remarkable. Not more comforting, the universe is not structured for our comfort, but more remarkable. The fact that matter organized itself at all, against the background of a universe that is 80% void, that gravitational complexity arose in a cosmos that is overwhelmingly empty, that stars and planets and oceans and living things and minds emerged from a set of initial conditions that, extrapolated forward, produced mostly nothing. That fact is not trivial. The cosmic web is not the norm, it is the exception. The dense, luminous, causally connected regions of the universe, the filaments and clusters and galaxies, where chemistry and biology and minds become possible, occupy a small fraction of the universe's total volume. The rest is the Boötes Void, repeated, in various sizes, in every direction, for as far as observation reaches, and presumably beyond. We happen to exist in the exception, in the narrow, improbable band of density, where the conditions for complexity are met. This is worth dwelling on. Not in a way that should produce comfort or reassurance. The universe's indifference to human welfare is not altered by the fact that we're here, but in a way that should produce a specific kind of awareness. The complexity we take for granted, the richness of the world, the density of interaction, the layers of organized matter that surround us at every scale, is not what the universe defaults to. It is what happens at the intersections of the cosmic web's filaments, in the small fraction of space where gravity has concentrated matter beyond the threshold that allows stars to form and burn and die and seed the next generation of stellar and planetary systems. Everywhere else, the vast, cold, dark majority of the cosmos is void. You are not in the void, you are in the exception. And the exception, it turns out, is where everything interesting happens. But here's the thing about exceptions. They are defined by what they are not. The Boötes Void is not just an empty region of space. It is the context against which the cosmic web structure becomes visible. Without the voids, the filaments would be indistinguishable from a uniform distribution. Without the darkness, the light would have nothing to contrast against. The void is not a failure of the universe to produce structure. It is a necessary feature of a universe in which structure exists at all. You cannot have a web without the empty spaces between its threads. The Boötes Void, in the end, is the complement of everything. The negative space in the image of the cosmos. The silence that makes the signal audible. The dark against which the lights of 100 billion galaxies in the cosmic web's dense regions manage to stand out as something other than uniform brightness. Without the void, the universe's structure would be invisible not because there would be no structure, but because there would be nothing for it to contrast against. The existence of the great nothing is what makes the great something legible. This is not a comfortable philosophy. It doesn't resolve into the kind of meaning that feels personally relevant in the way we usually want meaning to feel. It doesn't say that you matter, or that the universe is on your side, or that the darkness has a purpose oriented toward anything you can identify with. The void doesn't care about that. Nothing in the cosmos does. But it does say something about the relationship between absence and presence, between emptiness and structure, that goes deeper than the simple observation that the universe contains both. It says that they are not independent features. That the scale of the emptiness and the scale of the structure are coupled, that a universe with larger voids would also have denser, more extreme filaments, and a universe with smaller voids would have less concentrated structure. The two features grow from the same initial conditions and are governed by the same physical processes. The Boötes Void and the Virgo supercluster are, in this sense, mirror images of each other. One is the universe at maximum depletion. The other is the universe at high concentration. Both are necessary products of the same 13.8 billion years of gravitational dynamics operating on the initial fluctuations of the Big Bang. We exist inside one side of that pairing, the side with matter, with stars, with the conditions for chemistry and life. And we observe the other side, the void, from a distance of 700 million light-years through instruments that detect the faint signals at its edges, and we try to understand what we're seeing. What we're seeing is ourselves, inverted. The universe as it would be without us. The universe as it is, almost everywhere. Now there is a final thing. Something that has been waiting in the background of this entire conversation, something I've been circling without quite arriving at, and it's time to land on it directly. The Boötes Void is the largest void we have found. But we have found it because we have looked. Because humans on a small planet, in an ordinary galaxy, in a dense region of the cosmic web, built instruments sensitive enough to map the distribution of galaxies across hundreds of millions of light years. Because they looked at the data and noticed the absence. Because they asked what the absence meant and developed theories and ran observations and refined their understanding over decades. Because the same kind of organized complexity that the cosmic web's dense regions make possible chemistry, biology, minds, language, science turned its attention outward and mapped the structure of the universe, including the structure of its own inverse. The Boötes Void did not know it was being observed. It does not know it now. It will not know when our observations of it improve, when future surveys map its interior with greater precision, when the physics of its origin becomes clearer. It is indifferent. It is empty. It is exactly what it is, whether or not anyone is looking. But something is looking. Something that emerged from the exception from the narrow band of matter-dense space, where organized complexity is possible, turned its attention toward the void and understood it. Not completely, not without residual uncertainty, but genuinely, meaningfully, in a way that goes beyond pattern matching or instinctive response. Understanding the Boötes Void requires abstraction, mathematics, the ability to reason about scales and times that exceed direct experience, by dozens of orders of magnitude. It requires the specific kind of intelligence that only arises in the dense, organized, causally complex regions of the cosmic web, in living systems with enough metabolic energy and neural complexity to model the universe far beyond the immediate environment. The void produced no such intelligence, could not have, does not. The conditions for that kind of complexity were never present there, and the accelerating expansion of the universe ensures they likely never will be. The void is, and will remain, the part of the universe that cannot understand itself. We are the part that can. Partially. Imperfectly. Always from a fixed position with limited information, looking outward into darkness that extends far beyond what our instruments can reach. But genuinely, we are a region of the universe that has developed the capacity to model other regions of the universe, including the regions that are nothing at all, including the great nothing that sits 700 million light-years away in the direction of Boötes and extends for 330 million light-years in every direction from its center. That capacity, the universe modeling itself through the organized complexity that arises in its dense regions, is not a guarantee of anything. It doesn't come with protection or purpose or permanence. The sun will eventually expand and incinerate the Earth. The Milky Way will eventually merge with Andromeda. The last stars will eventually exhaust their fuel. The last black holes will eventually evaporate. Whatever understanding has been built will dissolve back into the undifferentiated heat death that the universe is slowly drifting toward. The capacity for understanding is temporary. Everything in the universe is temporary, but it exists right now, in this moment, looking outward. And out there, 700 million light-years away, the Boötes Void sits in the dark, growing slowly, 3 degrees above absolute zero, patient in the way only something without experience of time can be patient. Its 60 galaxies drift in their filament. Its boundaries expand. Its interior deepens. It has been doing this for hundreds of millions of years. It will keep doing it for hundreds of millions more. Long after everything that currently knows about it is gone, the void will persist. Longer than any star now burning. Longer than any civilization now imagining it. The great nothing will outlast everything that has named it. There is something in that thought that wants to close, that wants to find a resting place and settle. A conclusion. An endpoint. But the universe doesn't close, and neither does the real question underneath everything we've covered today. Because if the Boötes Void is the largest void we have found, the obvious question is, what is the largest void that exists? Not that we've discovered, not that lies within the observable universe. What is the largest void that exists in the full extent of the cosmos, including the regions beyond our horizon that we will never observe? We don't know. We cannot know. The answer lies permanently beyond the reach of any instrument we could build, in a universe that is almost certainly vastly larger than the sphere of space from which light has had time to reach us. And the inflationary models that most accurately describe the early universe, the models that best fit the data we do have, suggest a total universe so large that the observable portion is, relative to the whole, essentially, a rounding error. In that larger universe, in the dark regions beyond our horizon, in the vast and unobservable reaches that extend in every direction past the edge of what light has had time to show us, there may be voids that make the Boötes Void look like a minor underdensity. There may be voids so large that the entire observable universe, with its 2 trillion galaxies and its hundreds of billions of light-years of cosmic web, would fit inside them as a modest cluster fits inside the Boötes Void. The statistics of inflation, applied to the full implied scale of the universe, suggest that such structures are not just possible. They may be inevitable. The great nothing may not be the greatest nothing. It may be the smallest example of a category of structures that dwarfs it by factors we have no numbers adequate to express. And somewhere in that possibility, in the implication that the largest void we can conceive of is likely not the largest that exists, that the darkness deepens past our horizon into regions we will never illuminate, is a thought that resists completion, that keeps opening rather than closing, that takes whatever equanimity you've managed to build across this conversation and gently, irrevocably, undermines it. The universe is mostly void. The void is mostly unknown, and the unknown extends further, in every direction, than we will ever be able to see. Whatever that implies, and it implies quite a lot, it does not end here. There is another structure at the edge of our observable universe, a region so anomalous that cosmologists spent years trying to explain it before settling into a quiet acknowledgement that they do not fully understand it. It connects to everything we've covered about dark energy and cosmic structure and the limits of our knowledge. And it starts with a signal, a gravitational signal that pointed in a single direction in the sky for so long that the astronomers who found it gave it a name that has not been forgotten. That's where this goes next. But before we get there, I want to linger here for a moment longer, because there is one thread we've been pulling on throughout this entire conversation that hasn't been pulled all the way yet, and it concerns something more immediate than dark energy, and more personal than cosmological structure. It concerns what the Boötes Void does to the concept of home. Every culture, in every period of human history, has had some version of a cosmology, some model of the universe and humanity's place within it. Those models have varied enormously from geocentric to heliocentric, from finite to infinite, from eternal to created, from purposeful to indifferent. But almost all of them, across the full breadth of human cosmological thinking, have assumed something that turns out to be an artifact of our position. They have assumed that the universe is, broadly, full, that it is populated, that wherever you go, there is something: stars, gods, heavenly bodies, matter, structure, the presence of something rather than nothing. The discovery of the cosmic void structure, and in particular, the discovery of the Boötes Void, at its extraordinary scale ruptures that assumption definitively. The universe is not broadly full. It is mostly empty. Radically, structurally, irrevocably empty. The fullness we experience: the blue sky, the star-rich night, the planet beneath our feet, the molecular density of the air, is an extraordinarily local condition that applies to a vanishingly small fraction of the universe's volume. We are embedded in an exception so extreme that it shapes every intuition we have about what exists. This is not a new observation. Physicists and astronomers have known for decades that space is mostly empty by volume. But knowing it intellectually and actually confronting what it means are different things. The Boötes Void confronts you with it. It is not an abstraction. It is a specific, named, located region of the actual universe that is, as far as our instruments can determine, effectively empty across a span of 330 million light-years. It is the universe showing you, at maximum contrast, what most of it looks like. And most of it looks like the Boötes Void. That reconfigures the concept of home in a way that can feel, if you let it land fully, profoundly disorienting. Home, as a concept, implies a place where you belong, where the environment is scaled to your presence, where things are arranged in a way that sustains you. Earth is home in this sense. The solar system is home. In a slightly more abstract sense, our star, our planetary system, the gravitational environment that has shaped life for billions of years. The Milky Way is home, in a yet more abstract sense, our galaxy, the stellar community to which our solar system belongs. But the universe, taken as a whole, is not home. It is a vast, cold, dark, expanding expanse of mostly nothing, in which the conditions for life exist in a tiny fraction of the total volume, in the dense regions of a cosmic web that itself occupies only about 20% of the universe's space. You are alive in the most exceptional environment the cosmos has to offer, and the exception is surrounded on all sides by something that would end you in seconds if you were placed inside it, and extends further, in every direction, than any journey you could make in any lifetime, or any series of lifetimes, or any duration you can meaningfully imagine. Home is a small, bright exception inside a great nothing. That thought is uncomfortable. I understand the instinct to resist it, to find a framing that resolves it into something more manageable. But I don't think it should be resolved. I think it should be carried. Not as a reason for despair. The universe's indifference to human welfare says nothing about the value of human experience, which is entirely a human matter, constructed and maintained by humans for human purposes. But as a corrective to a certain kind of comfortable parochialism that tends to assume the universe shares our scale, our concerns, our implicit sense that things are arranged for our benefit. The universe is not arranged for our benefit. It contains, 700 million light-years away, a region 330 million light-years across, in which nothing that could benefit or harm any living thing has existed for hundreds of millions of years. It contains, beyond our observational horizon, regions potentially far larger and far emptier. It is dominated by volume, by cold and dark and silence. We are the exception, not the point, the exception. And exceptions, as I said before, are defined by what they're not, by the context that makes them visible, by the contrast that gives them shape. The Boötes Void is not incidental to our existence. It is, in a strange and non-obvious way, part of the structure that makes our existence possible, not because it contributes anything physical to our environment, but because it is part of the same cosmological process that concentrated matter into the filaments and clusters, where stars form and chemistry becomes possible and life emerges. The void and the web are one system. The emptiness and the fullness are one process. You cannot separate the Boötes Void from the Milky Way any more than you can separate the space between soap bubbles from the soap film itself. They are features of the same structure, products of the same physics, results of the same 13.8 billion years of gravitational dynamics operating on the quantum fluctuations of the early universe. You are here because of everything that happened, including what happened in the Boötes Void, including the matter that drained out of that region, pulled toward the dense attractors of the forming cosmic web, leaving behind the emptiness we now observe. That migration of matter, the slow draining of a region 330 million light-years across over the age of the universe, contributed, in the most diffuse and distributed sense, to the concentration of matter in the filaments where solar systems and planets and oceans eventually formed. The Boötes Void is not just the universe's largest empty space. It is, from a certain angle, the origin story of its own surrounding structure, an emptying that helped fill somewhere else. Matter does not appear from nothing, and it does not disappear into nothing. It moves. And the movement of matter away from what is now the Boötes Void, driven by gravity toward the forming structures of the cosmic web, over the first few billion years of the universe's history, is part of the same redistributive process that eventually put matter in the right place, in the right concentrations, to allow stars and planets and living things to exist. Now, let's return to something we haven't fully closed the question of whether the Boötes Void is truly anomalous in a way that current physics cannot accommodate, or whether it sits just within the edge of what the standard cosmological model predicts as a rare but possible fluctuation. This question matters more than it might appear to, because the answer has implications for the foundations of cosmology. If the Boötes Void is a statistical outlier within the standard model genuinely possible, just very improbable, then our physics is intact. The void tells us something about the range of structures the universe can produce, but it doesn't require us to modify the framework. It is a surprise, but a containable one. If the Boötes Void is genuinely too large to fit within the standard model, without strain if its size and emptiness require a degree of early universe density fluctuation that the standard model considers implausible, then the void is a probe of physics we don't fully understand. A hint that something in our cosmological framework is missing. An anomaly in the precise sense. A data point that our best theory predicts should be extremely rare, but that exists nonetheless. The current scientific consensus leans toward the first interpretation, with caveats. The Boötes Void can be accommodated within standard cosmological models, but it sits at the edge of accommodation. It is not a clean fit. It is the kind of data point that, if several more like it were found, would begin to create serious pressure on the framework. So far, no void of comparable size has been confirmed. The Boötes Void remains, as far as we know, genuinely exceptional, not just the largest void we've found, but potentially one of the largest voids that the standard model predicts should exist within the observable universe. The honest answer is that we don't know. Our galaxy redshift surveys are extensive, but not complete. The full three-dimensional map of the observable universe has not been made with sufficient resolution in every direction to rule out the existence of other comparably large voids. The Boötes Void may be unique, or it may be the largest member of a class we've only begun to catalog. The data is not yet sufficient to distinguish between those possibilities. What we can say is this: the universe, within the volume we can observe, contains at least one void of 330 million light-years across. That fact alone is remarkable. In pure volumetric terms, the Boötes Void span represents an extraordinary concentration of nothing. A region of space that, if filled with matter at the average density of the universe, would contain enough mass to form hundreds of millions of Milky Way-sized galaxies. Instead, it contains 60. The ratio between what should be there, by average expectation, and what is actually there, is one of the starkest ratios in observational cosmology, and it sits in the sky above you right now, patient and enormous, and pointed out by an astronomer's finger drawn from the Big Dipper to Arcturus. You have always been able to see approximately where it is. You have always been, in some sense, in its presence at a remove of 700 million light-years, which in cosmological terms is a modest distance, well within the observable universe, within the sphere of space that has had a causal relationship with our own region since the Big Bang. The universe we live in is not a universe arranged for human habitation, not a universe scaled to human experience, not a universe in which the conditions of our daily existence, warmth, light, matter, gravity, complexity, represent anything like the norm. But it is a universe in which those exceptional conditions exist, here and in the other dense regions of the cosmic web, and in which beings capable of asking about the universe's structure have, by pure accident of position, found themselves in exactly the kind of environment where such questions are possible. The Boötes Void cannot ask questions. It cannot model itself. It cannot register its own existence. It is 330 million light-years of the universe that will never know what it is. We are a few light minutes of the universe that does. And somewhere in the territory between those two facts, between the great nothing and the small exceptional something that is currently trying to understand it, lies everything that matters. Not to the universe. The universe doesn't deal in matters. But to us, in the only context where mattering is a coherent concept at all, there is a much darker implication to all of this that we haven't fully touched yet. One that starts not with the Boötes Void, but with what was found moving toward it, a gravitational anomaly. So large and so unexplained that the scientists who detected it spent years arguing about whether it was real, and then spent more years arguing about what, if it was real, could possibly be causing it. Something enormous. Something that sits beyond our observational horizon. Something that is, by definition, in the region we cannot see, in the darkness past the edge of everything light, has had time to show us. The astronomers who found it gave it a name that carries weight in proportion to what it implies. They called it the dark flow, a coherent movement of galaxy clusters across scales of hundreds of millions of light years, all drifting in the same direction towards something beyond the observable universe's edge that exerts a gravitational pull large enough to set the large-scale structure of our observable sphere in motion. What is large enough to do that from beyond the horizon? What structure, in the unobservable dark, pulls at the matter inside our visible universe with enough force to produce a measurable flow across hundreds of millions of light years? That question has no confirmed answer. It has proposals. It has models. It has implications that, if any of them are correct, would force a revision of how we think about the universe's structure at the largest scales, including, possibly, what lies in the dark, beyond every void we have ever found, including the great nothing itself. That's where this continues.